Coffee. We're back in the shop. If you're just joining us for the first time, welcome. We're a pretty friendly shop here. There's me, Paul Brodie, Mitch behind the camera. Good job as usual. We're working on the Tiger Cub here, and this is going to be a bit of a challenge because it's kind of a complex thing. I've got an ignition system here, which I purchased. I bought all the Cub stuff. I looked it up this morning on the 6th of June last year. In 2021, I purchased a bunch of Cub stuff. A couple months into the project, someone told me that, oh, you need a ignition system. You should buy a Electrics. So that's what I got, Electrics with an X on the end. And so I thought, okay, this is great. And then I realized that how this mounts, here's the primary chain case, and this mounts inside. Can you see here all the studs? You take out this one, you add that one. It mounts onto the studs there. So what happens is when you pull off the case, unless you drill a hole through here and you poke the wire out, it's hard to take off the case because this wire goes into here. Another problem with this is that you can't check the timing of the ignition because you can't put on a degree wheel. This is what I like to use, and this will mount somewhere like that. You have a pointer, you start up the motor, you have a timing light, and you check where the spark is. So with this system here, you just have to guess. So I didn't like that. So what I wanted to do was to mount this on here. This is the rotor, this is the stator. So that's going to get mounted like that. And it wasn't long after I got this that I found out about this system here. It's available in the UK off a company called Off, I think. Strange name. So they have a system here, and it's got a PVL unit. So after I found out that, I thought, oh, well, I've got this. This is a nice unit. So I wrote to them. I sent them an email. I asked them if they would sell me this piece of aluminum here, which is CNC machined. And I didn't even get an answer. So what I want to show you is the bolts. These are the bolts that hold the crankcase. It holds this half onto this half. Can you see how it goes down like that? Well, when you have a system like this, can you see how it's raised up? You need a longer bolt. So I wrote to these people. I said, I'm interested in those bolts. Would you sell me those bolts, Allen screws? And they said no. So then I said, well, okay, then that's fine. Would you tell me where I can buy them? And they said no. So I thought, oh gosh. So I searched the internet, and I had other people looking as well. These bolts are really hard to find. It's an odd thread pitch of 22 threads per inch. So I could not find the Allen screws. So if you don't have the Allen screws, you can't hold it down. So here's my solution. Let me show you this. I bought an 8mm Allen screw that's too long. This is stage one. I center drilled it. I machined it down. There's the nut. The nut's gone. And so the nut goes over top. And then I put it in the lathe. And I machine my longer Allen screw. So I think that's the first step we're going to do today. I did this one yesterday as a test. So we're going to go over to the lathe and we're going to do some machining right off the bat. And then we've got a big chunk of aluminum, a $40 piece of aluminum. That's how much this cost me. I don't have a drawing, but look. I got cardboard cutouts, I've got notes, I've got all sorts of stuff. So I think it's going to work. And I also have other notes as well. So no drawing, but sketches and notes. Let's go to the mill. No, the lathe. Let's go to the lathe and do some machining. We're going to cut some threads. Okay, we're getting close to the thread depth now. What I have to check now is the OD, because as you cut this, it raises up the surface. And when I was doing it last night, I found that this was oversized as compared to the regular bolt. So we have to do a little bit of filing now. Okay, this is what I want to show you. Here's the thread. This is the standard bolt, and it's at 306. And this here, see, it's at 310, probably more up there, 312. I have to file that down to get this. I have to get the same OD as this bolt here. So. We're on 306. 306. Okay, so same size. So now we got a little bit more to take off, and then we'll see how the nut fits. Okay, so the nut goes on, and last night when I was doing this, I got the nut on there and I thought, great. So I want you to see this. It doesn't have any slop. There's very little slop. It goes on, but there's no slop. So when I grab this and I put it on here, can you see how it spins on? Can you see this slop there? That's what I want, because I made this one yesterday and the nut went on it, but it wouldn't fit in the case because I didn't have enough of a thread depth. So I learned last night, and that was a lot of work to make this one fit. Had a diamond file, a triangular diamond file, and I'm on the lathe and I'm filing down the thread to make it fit into the crankcase. So I can't say it was smooth sailing. So we're going to take off a little bit more because we need that slop. Just a little bit of slop to make it fit. That took a pretty healthy cut. There, okay, you can see that move, can't you? We're going to cut that off. We're going to see if it fits in the case because we got so much more to do today. Half an hour to make one thread on an Allen screw. How long can it take? It's a hard piece of metal. So here's the new bolt. We're going to put on some anti-seize here because we don't want it galling or anything like that. Let's see how it fits. This is first try. Look at that. That one goes in a little easier than the first one. That's good. Okay, beautiful. So now I can show you a few things on the engine here. So what's going to happen is this is going to get machined, and it locates into this hole and this hole here. These bolts get hidden under the sprocket, so you don't see those ones. But these two are what holds on the plate. And there's also a third mount that goes here. This is CAD design. It's cardboard aided design. So if I take my screws here like this, I spent a few hours doing this, figuring it out. And so the tensioner has to go in here for the chain. So I'm going to make a tensioner out of Delrin. You can see there, and that's the shape of it. See, I've got a hole there. That's where the pivot is. I want to show you a couple things. I like the concept of this, but on the tensioner, it's only held on one side, and I don't like that because you've got, I mean, this is a very, very strong motor. It's probably got 16 horsepower, and I don't want the tensioner to be held just on one side. I also want you to notice that it's fairly flat. My tensioner, I know, like if I hold it at the same angle, can you see how this one here has a lot more curve to it? On the crankshaft, it goes anti-clockwise looking from this side. So I think that how the chain fits, it wants to do a nice arc. So that's what I've got here. I've got the pivot down there. Can you see that little circle there? And so that fits like that. What happens on this one here, it wants the chain to go like so. Because it's flat, right? It's flat and then it ends. I don't think that's natural for the chain. I think the chain wants to naturally arc. If you look at photos of a race bike, for example, as the bike's under acceleration, on the lower part of the chain, it always arcs up as much as it can. So my design, here's the two pieces, and the tensioner is going to go in between. So I came up with this design because there's not a lot of room for nuts or anything like that. So you can see how the shaft has a little shoulder here and it fits into the bottom plate. On the top plate it sits a little proud, and there's a plate with two Allen screws there that holds that shaft down. So that's what I'm going to make. And that's going to be made out of this plate right here. I've got those two holes marked, so I think it's time to go to the mill. Milling time. Going to the bandsaw now. We're gonna cut out a shape here so I don't have to mill as much. Put some bug juice on here. There we go. Okay, while the mill's like it is, I think we're gonna drill a big hole right there. That's gonna let the crankshaft come through. This mounting system for the ignition system, it gets held one spot here and two spots here, and there's a third spot here. It gets held right here. If you look at the drawing here, that is the third spot, and you see there's a bolt or an Allen screw that goes through. That's the Allen screw right there. Why I'm showing you this is because this is a casting, and to get the casting out of the mold, you need a draft angle, usually of 2 degrees. Can you see how this is not perpendicular? That's basically perpendicular. There is a draft angle there. So what they've done on this system here, can you see how this is angled a little bit, and there's a radius right there because the radius has to fit right here. See that corner there? That's where it goes. So what you have is a flat surface. You have a flat surface and you have a round surface, and you're asking those to mate nicely. So I've got the engine all apart. So what I'm going to do is I'm going to set this up in the mill now. I'm going to use a 5/8 end mill, and it's going to come right down there and face a little bit on the bottom. It's going to go in a little bit as well. And then we're going to take a rod, and that rod is going to be held in there. So this is going to be way more secure. And then it's going to get center drilled in the lathe. And then when I put on this piece here, I dial up to the center drill, or I just put a center drill in there, and then I drill the hole through the plate. Everything's perfectly in line. That's the plan. So right now what we're going to do is to take this apart. We'll just have this left-hand crankcase, and we're going to mill down. Next job on the mill. So we're slowly working through all these little areas that have to be attended to. Can't think of anything else I'd rather be doing. There we go, that's all we need. I can't take too much because I'm getting too close to this surface here, so I have to be careful. That's what it looks like. See, I've got a nice little 5/8 cut, 5/16 radius. Now we just need a piece of aluminum to go in there. If I got a drill the right size and I made a felt pen mark on this, that's one way of, maybe not totally accurate, but let's try it. If we hold that in like that, is this an approved method? What do you think, Mitch? Or is it reeking of Mickey Mouse? Hopefully not. So there we go. There's a mark. I think I can get the center out of that. So we're going to center drill. We're going to drill a 1/4-inch hole, and then we're going to countersink. And then we'll see if it fits. Oh, look at that. That's a good fit. That fits quite nicely. I'm going to glue that in as well, I think. So anyway, could be a little longer. But so that's some progress. We have to drill a hole in the lathe now. We'll do that after. It's been great having you in our shop here. Thanks for coming along. I hope you enjoyed watching this. It's a bit of a project I took on here. We'll see you next time. You take care. Stay safe. I wanted to show you something. It's the flywheel I was going to use. And I had this other flywheel in there just for, you know, just to hold things in place. What I want to show you is this. Can you see that? Is that worn out? Can you see how much movement there is? Look, you can even see the heat stains there, how it got so hot. I can't imagine how much noise this engine was making. And then I was looking at it. Can you see here? They hammered so hard. Can you see there's a crack going right from the crank pin right up to the edge of the flywheel? So these little cubs, sometimes they got really abused, like seriously abused. I feel sorry for them.